So let's move to another interesting board, and that is where most of the people finding it to be confusing, right? But here is the board which is designed to make sure that you understand this, right? Now, I'm taking an example where I have written down these 4 routes. And by the way, guys, just presume for now this here, this one, this interface is down, and I have defined 4 static routes. Okay, the 4 static routes are 10.10.10.0/24, which could be reachable from 12.2, right? This router. What I'm doing, I'm just doing the change on the network number bits, right? This one is /24, this one is /25, this one is /26, and this one is /27, right? What we are learning here, we are learning longest match route. For now, just leave about what is the meaning of longest match, but try to understand. And by the way, guys, this next hop could be changed here. For example, you can always write down that 10.10.10.0/27. If you have another router, maybe R3 here, you can say that it is reachable over R3 also. The next hop can be changed. So it is not the case that next hop could not be changed in this. You can define any next hop. You are in charge of creating these static routes, right? But let's try to understand, first thing first, what these routes are saying, right? This is my first route, which is 10.10.10.0/24, which I am saying it is reachable over FA0/2, and the next hop is 12.2, right? What is the meaning of it? The meaning of it is that it contains 128 hosts. Sorry, extremely sorry. It contains 256 hosts. The first IP address is .0 and the last IP address is .255, and there are range of IP address between it, which is .1 to .254. .0 is your network number, .255 is your broadcast number, right? This is my network number 1 here, this one, right? Now let's talk about what we are changing. We are changing in network bits. Now it is becoming /25, right? So 10.10.10.0/25. Now you can understand that the host bits are going to be 7. Network bits are 25 because here we write down the network bits after slash. The host bits are going to be 7. It means that 2 to the power 7, which is 128. So we are going to have 128 hosts here. The first IP address of this host is .0, and the last IP address is going to be 127, because if you count 0 to 127, the number you get is 128, and there are many numbers or many IP addresses which are .1 to 126. .0 is the network number, .127 is the broadcast number. Let's talk about network 3. And there is a specific reason I am writing down the range, but now you know subnetting. If you are not getting it, what I am explaining you here, it means that you have missed one of the class or two of the class from last 6 classes, right? Let's talk about the third network. The third network is 10.10.10.0/26. And if that is the case, now we are talking about 6-bit for the host. It means that 64 hosts, right? So here you go. We have 64 hosts here. The first IP address is going to be .0. Again, the last IP address is going to be .63. It is as simple as that. And in the middle, you are going to get the number from .1 to .62. The last thing, let's draw it quickly. Network 4, which is going to be 10.10.10.0/27. It means that you have only 5 bits now for the host. It means that you are going to have 32 hosts IP addresses .0 to .31, and from here .1 to .30. It is as simple as that, right? First network contains 256, second network contains 128, the third network contains 64, and the last contains 32. Guys, believe me, all of these networks are different, right? Previously, when we were talking about in terms of administrative distance value, the network was same. The network was 10.10.10.0/24, but here network is totally different, right? Although you can argue with me that these network, okay, we can say these are different network, but yes, network 2 is completely present in network 1, right? Because network 2 is from .0 to 127, and network 1 contains .0 to 127, but it contains more hosts also, right? Similarly, network 3 is there in network 2 and network 1, but absolutely it is more specific because network 1 contains from 0 to 254, network 3 contains from 0 to 0 to 63. It means that it giving you more specific information about the network, right? Similarly, network 4 is giving you more specific information because it is having only 0 to 31. Network number 1 is the biggest one, right? As simple as that. But at the end of the day, if I tell you all of these networks are different, and if these networks are different, then there is no question what should go into the routing table. If the network is different, then every network should go inside this routing table, right? We are going to write in router R1 routing table that we have a static route. First thing first, for 10.10.10.0/24 via router R2, right? You can calculate them, you can write it down here FA0/2 as well as 12.2, but for simplicity I am writing this. The second route which is going to go here is 10.10.10.0/25 via again R2. Third route which is saying 10.10.10.0/26 again via R2, and maybe this could be your R3, this could be your R4, and maybe R5 also. If we have different next hop, maybe this IP address gets changed, maybe this IP address gets changed, right? And at the last, we have last one, which is saying 10.10.10.0/27 via, actually it should be R2, but I'm writing R5 so that there is no confusion. Maybe see, this is connected to R3 also, one route here. This is connected to R4. This is connected to R6, and you are making this router confused, but router is not getting confused because router understand that these 4 networks are totally different. And if these 4 networks are totally different, every route should go inside this routing table. It is as simple as that, right? The confusion was when we have only one route, 10.10.10.0/24, right? And which was learning through connected route, static route, OSPF, EIGRP, what route should go here into the routing table. Then we have the confusion because we have only single network here. But here we are talking about different networks, right? So there is no question which should go into the routing table. So try to understand. Do not get confused with it, right? But yes, your point is valid. What is going to happen if I just log in into this router and make sure that this interface is not shut? I logged into this and run a unshut command here. Now there is a question, right? What is the question? We have another route which is 10.10.10.0/24, which is learned via connected. Then there is a confusion because we have this route and we have first network here, this one, right? This is learned via static route, or the first network 10.10.10.0 is also learned via static. Then we know which route should go into the routing table. If you unshut this interface, this route will going to be, because this is the static route, will be eliminated from the routing table. Absolutely, it should not be here. And you will be see the connected route here. Why? Because now we are talking about the same subnet. Does it mean that the other subnets are going to be vanished? No, because these are totally different subnetworks or the networks. Which route is going to be replaced? Only the one. So when you unshut this interface, the router is going into routing table and see that whether it has this route or not. It sees that it has this route, exact same route, the first one, right? And now it is running what via connected. Connected has the lowest AD value, and that is why this static route is replaced by this connected. As simple as that. But other networks, those are not the same networks like this. Those should be into the routing table, right? Now, the question arises that there is no point here if you define, and now I am again shutting it down, so that right now here it is again static route. You can run this experiment. So now basically I am talking about that this is again static route, right? Because I have shut down this interface once again. Now the question arises. That is fine. There is no doubt which route should go into the routing table. All of them, network 1, network 2, network 3, network 4, all will be there because these are different networks. So there is no doubt about it. There shouldn't be any doubt about it. Now the question arises, if a packet comes over this router, right? This one. And the destination of the packet is say 10.10.10.10. The source is x.x.x.x. Say which routing table is going to select to move this, because the next hop in every case is different, right? If route number 1 is selected, because this host is the part of route number 1, right? Because route number 1 contains the host from 10.10.10.0 to 10.10.10.255, and this is the 10th host, right? So the destination IP of this IP packet is going to be matched by every network or every route, every static route in this routing table. The question should be which route is going to be matched against this IP address, because this host is in the first network also, absolutely, in the second network also, in the third network also, and in the fourth network also, which is going to be selected. And for that, I would like to give you an analogy, right? Suppose we have our character, Mr. Rahul here, right? Right here. And Anjali wants to reach out to him. Maybe she wants to go to his house, right? What she needs, she needs actually the address of Mr. Rahul. Suppose she doesn't know, right? She's getting one information, right? And suppose the complete IP address, sorry, complete address of Mr. Rahul, and here we have Anjali, is going to be that Mr. Rahul lives in a number which is 301-2, which is its apartment number. He lives in ABC colony, or maybe ABC, the name of the apartment is ABC, right? Maybe he lives in a little town which is Sarjapur, inside Bangalore. Bangalore is in Karnataka, right? Karnataka is in India. India is in basically, you can say it's on Earth, and basically Earth is the part of my solar system, right? So this is the complete address. If somebody means you can extend this, whatever your knowledge is with respect to solar system, maybe you are part of Milky Way galaxies. There are so many galaxies here. But the whole sole point is you can identify, you can reach to Mr. Vishnu. Even somebody from other planet also can reach to Mr. Vishnu because you are pretty thorough in it. You are saying I'm part of solar system. I live on Earth, India, Karnataka, Bangalore, Sarjapur, ABC 312. It's my complete address at the solar system level. Simple, right? But now Anjali wants to reach to Mr. Rahul, and Anjali is getting different information. Somebody comes to Anjali and said, Anjali, Mr. Rahul lives in solar system. Interesting, right? Somebody else come with more specific information because solar system contains multiple planets. Somebody says that Mr. Rahul lives in solar system and basically he is on the Earth planet of the solar system. Somebody comes with more specific information, right? And this time the information is that Vishnu lives actually on Earth, or this Rahul lives actually on Earth, which is part of your solar system. And on Earth, basically, he is in a country called India. And basically, inside India, he lives in a state called Karnataka. At last, some more specific information towards this Anjali, that if you want to reach Rahul, then Rahul lives in this number 312. His apartment name is ABC. He lives in Sarjapura, Bangalore, which is part of Karnataka, which is part of India, which is on Earth, and which is on this solar system. Which information Anjali like to process? Whether this first one, second one, third one, fourth one. Of course, she is going to process everything, right? Because everybody is giving her the number. Where exactly, address, where exactly, what is the address to reach Mr. Rahul, right? But if he has information of all of this, if he got the information, and I have written down this information into number 1, 2, 3, 4, which information, because if it has all the information, she is going to believe number 4, because number 4 is more specific. It is giving me more information with respect to Rahul, right? There are more chances that Anjali is going to be reached to Rahul's address if she follows this, because this is a logical understanding. But suppose if somebody is saying that Rahul lives in solar system, there are pretty less chances that Anjali can go and find it there, right? Although the information is correct that yes, Rahul lives on solar system, right? But suppose if this information is not there at all, if this source is down, then absolutely she is going to believe another specific information which is less specific than this, which is this one. But absolutely it is more accurate than this one. So what is the whole sole point? The whole sole point is, if this router is getting two routes, one is 10.10.10.0/24 and the another one is 10.10.10.0/25. The question here is, which route should be considered by this router when it has to send the packet, and the packet destination address is suppose 10.10.10.10. Both are part of this network, just like everybody is giving the right information, right? But the router is going to match exactly one route. Maybe it is going to say that you can reach this network via router R2. Suppose this is R1, and you can reach this route via router R3. It is learning to complete in different information, right? Maybe R2 is somewhere here and R3 is somewhere here. Where this IP packet right here should go, towards this router or towards this router? This is the interesting question, right? So basically, you need to send this IP packet to it towards say next hop, right? And by consulting or with consultation of the route which is giving more specific information, this route is giving what? This route is giving the information about 256 hosts, right? Because of the /24. This route is giving information about 128. Which information is more specific? This is basically somebody is saying this is your solar system, and this is saying, okay, solar system plus Earth plus India, say. If that is the case, router is going to believe the more specific information, which is 128. And this route is going to be matched against, this IP packet is going to be matched against this route, which is 10.10.10.0. And this router is going to send this IP packet towards this destination, towards R3. As simple as that. But if this route is not there at all, if somebody, then router doesn't have any choice. He's having this route, and then basically it is going to send this route over R2. The router is going to believe the more specific information. I know that you might say that Mr. Vishnu, this host 10, which is 10.10.10.10 is in this network also. And the host 10 is in this network also. And absolutely. But who is giving more information? This guy is giving information about this host as well as 255 other hosts also. This guy is giving information about this host and only 127 other hosts, right? If you go, right, what you are doing here, you are just changing the network bits. Previously 24 was the network bits. It means that the hosts were only 256. If you make 225, the host will become 128. If you make it 26, the host will become 64. If you make it 27, the host will become 32. If you make it 28, the host will become only 16. Similarly, if you change the network bit to 32, the host is only going to be 1. Right? If I say 10.10.10.10/32, what it is doing? It is having on 0 bit. It is having 0 bit for what? Host. And 2 to the power 0 is what? Only 1. It means that it is going to specify only one host, which is 10.10.10.10. So if you are going to have, maybe if you are going to have all of these routes, 10.10.10.10/24, at last route is 10.10.10.10. Which route is going into the routing table? There is no doubt about it. All of these network are different. All of the route will be getting installed in the routing table. Which route is going to be used for the forwarding of this packet, which is having the destination IP address of 10.10.10.10? And there is no doubt about it. Router is going to be selected the last one, which is 32, which is specifically mentioning that this host is reachable over maybe some router R10, right? It is as simple as that. So let's move to our board now, right? The previous board. And you can identify right here that if the packet is coming here, then the most specific route is going to be this one, with highest number of network bits, because if the number of bits are more, here they are 27, the hosts are going to be less, which are 32. Previously it was 24, so it was 256. So just try to understand, if the starting number seems to be same, right? And you know that it doesn't matter what you write before slash, because the IP address has a logic, and that logic can be defined when you specify the network mask bits or network bits, right? The more the number of network bits, it means that the less the number of hosts you have. It means that the most specific network you are having. And that is why you say to match the IP packet, you need to do the match on the longest route, right? And what is the longest match route? You are calculating on the basis of longest or the greatest network number value, network bits value. So of course, out of 24, 25, 26 and 27, which one is the longest match? 27. Why the longest? Because it is going to have less IP host. And if it is going to have the less IP host, it means that it is most specific one. As you can consider, if it is 32, then basically we are going to have only one host, which is most specific. And 32 is the largest number as compared to 24, 25, 26, and 27. It means that it is the longest match, as simple as that. So router, when forwarding the packet, going to match the longest route or the longest prefix, as simple as that. Why? You know about it now. Having said that, I am open for questions now, and I could see that there is a question from Burak. Burak, please do ask your question.
Okay, thank you, Vishnu. As a summary, can we say that both routes exist in the routing table? Router is just selecting which route will be used for a specific destination. Am I right?
Absolutely. And this people don't understand this, right? Previous board was all about selecting the route from different sources. Here, the route was same. The route is actually 10.10.10.0, which was learned from here and here and here, right? And now the question was here basically the question was definitely correct. Which route should go into the routing table, whether the connected one, whether the static one, or whether the OSPF one, and you decided on the basis of AD. But if we talk about which route should go into the routing table, there is no doubt about it. The network is totally different, right? All the routes should go into the routing table. But yes, the question should be, which route should be considered when this router is forwarding the packet inside the host of these network. As simple as that. So suppose if a packet comes with the destination address of 10.10.10.100 and say 75, whether this host is in this network, the below one? No. Although it is having the subnet mask /27, but it does not have this host, right? Because the range of this is from 0 to 31. Which route is going to be matched by this 175? Absolutely this one. Because 175 is lying only in this route, only and only this route, right? 175 is not in here, not in here, not in here. So this will be forwarded towards R2. As simple as that. But if there is a confusion, suppose we talk about a host which is say 10.10.10. maybe 35. Of course, this host is not going to be there. And let me choose some another color pen. Maybe let me choose this blue one. This route is not there at all here. Sorry, this host is not there, but this is going to be part of these starting 3 networks. It is there in this route, it is there in this route, and this is there in this route. And if that is the case, then basically most specific route is going to be matched, which is /26, which is saying that forward this packet. Which packet? 35. This one, this IP packet. Forward this towards R4. It is as simple as that. I think, Burak, you got my point, right? But yes, your understanding was absolutely correct.
Okay. My second question is not about static routes. It's small questions about OSPF. May I
No,
ask
no,
these
no.
questions
OSPF,
after?
yeah, OSPF we will be seeing later, or maybe at the end of the
Okay.
class, right? But try
Maybe.
to concentrate on this board and previous board. If you have any doubt, any question, we can talk about it. Anybody else? I think there
Okay.
is a hand raise from Mr. Supreet. Supreet ji, go ahead.
Yeah, thanks, Vishnu. So let's say, for example, all these four routes that we are having in a routing table are learned via different routing protocols. So definitely they will be having different administrative distance. So no matter what is the administrative distance, the networks are different. So all the networks will find in routing table, right?
Indeed, absolutely.
Okay.
Yeah.
Okay. Yeah.
And I think the most of the confusion is out now with respect to longest match, with respect to AD value, right? I think
Yes.
yes. Yeah. Any other questions, guys? Because if you understand it, that is great. Because in the Hindi session, and this is the beauty, right? I have performed the Hindi session just 12 hours back, almost, right? And the example which I got from here was result of somebody asking that why I shouldn't consider this one, right? So this is good that we got the example already. So believe me, this is one of the most misunderstood concept because people are always asking this thing, right? And sometimes the people who is asking is not clear about it, and if you tell the correct answer also, uh, they are not agreeing with that. But yes, if you explain them with this analogy, with this route, with this way, they should understand it, right? So basically, at the end of the day, you can argue with me that why they have decided to do like that. Who? The TCP/IP developer. TCP/IP developers at the end of the day are the humans, right? They understand that if there are some information which is pretty broad, and there is some information which is pretty specific, more specific than more specific.